Assalamu alaikum. My name is Madhari Siddiqui, and today I have to explain this question. So let me share my screen. So yes, the problem is Kate missing positive number. Given an array of positive integers sorted in strictly increasing order and an integer k, return the kth most positive integer that is missing from this array. So basically, we have been given an array, and we have to find the fifth number, which is fifth missing number, which is coming in that array. So for example, in this array we have like 2 comma 3 comma 4 1. So 1 is missing in this array, as well as 5 is missing in this array, and then 6, but 7 is present. 8 is also missing, and then 9 as well is also missing. 9. So if you see carefully, we have to find the fifth missing number. 1 is the first number, basically first missing number. 5 with the second missing number. 6 is the third missing number. 4 is the 8 is the fourth missing number, and 9 will be the fifth missing number. So we have to return 9 as an output in this case. So our output will be 9. Okay, in this example 2, array was 1 2 3 4, and we have to return the second missing number. So if you see that it is already sorted and it is increasing, so the next number which is missing in this array is 5, which will be our first missing number. But after that 6 comes. 6 will be the second missing number, so we will return 6 in this case. So now look at, see the constraints. 1, the array length will be greater and equal to greater and equal to 1 and less than equal to 1000. The array number will be greater than equal to 1 and less than equal to 1000, and the kth, the missing character, will be greater than equal to 1 and less than equal to 1000, and the array I will be less than I. It means that it will be in simple words, it means that it will be in strictly uh, strictly increasing order, as it is mentioned in the question. So let's jump into the uh, algorithm which I implemented. Basically, I implemented a cyclic pattern. So let's jump to the algorithm. Here I have declared an array which have in zeros, and why I have declared multiply with this number, because the constraints were these. If I uh, for example, if I multiply the array zeros with 999, it will give the wrong answer, because the array length may be uh, uh, equal to 1000. So I have taken a number which is almost one time greater than 1000. So in this case 1001. So then I add the zeros array with the given array. I will explain why. Then I take these variables. Then what I did is I have taken a while loop. Basically, in this while loop, this is sorting the array. So now I'll explain the algorithm. Let me take annotate. Okay. So basically, as I told, 1, 2, 3, 4, 5, 6, 7, 8, 9. First we did is we sort the given array. We sort the given array, which was the array which was given us, the array which was given us before earlier. We sort that array. The numbers were given. Uh, numbers were, where is the annotation marker? Okay. 2 3 4 7. First we have to what we will get after the what we'll get after this, we will get an array which will contains zeros, all the zeros at their respective index except their 2 3 4. So now that is where is the, yes, okay, sorry for that. So 0 0 0 0 4 5 6, sorry, 0 0 up till to 1000 something. So basically we will get is after this while loop all the zeros in their respective index except 2 3 7 and earlier. So basically this is a zero as well. Basically this is a zero, zeroth index, this is the one index, second index, third index, fourth index, and so on and so forth. So basically what I did in while loop, basically I checked that if array position is less than equal to length array, it means that if we if I have, for example, if it have 44,000. So if we checked here that did our number does lie in the array or not. If it does lie, then we have to exchange that the number which is at this index. But if it doesn't, like in this case 44,000 is coming out of the index, so it will, what will do, it will jump to the else portion, it will discard this, and it the position will pointer will be moved to this. So so basically what it is, the while loop gives us this, simply this gives us this array at the end. After that what we do is we count, this is a 4 index, this is a 5 index, 6 7 8 9. Okay, after the while loop, if for loop is calculating that which index have the which numbers are not there in their index. For example, 0 index has 0 number, okay, this is correct. 1 index has 0 number, this is wrong. Basically the 1 index should have 1 number. So what we did is, our count variable was 0 earlier. What we did is we incremented by 1, so our count will be 1. Then 2 is at 2 index have 2 number, 3 index have 3 number, 4 index 4 number, 5 index have 0 number. So we add the count incremented. So this is also wrong, and this is also wrong. This is right, this is also wrong. When our count reaches to for example k, which is in this case is 5, so what I did is uh, I take that I take the index number, which is in this case is 9, and then give it in the output. In this way I get the output correctly. I have passed all the cases. uh, I will also run it and check it if it gives the right answer or not. Let's run the code. It will return the index in the end. It will count to the k target, and yes, it gives the right answer, and I submit it. After that we will look to the edge cases and as well as time complexity. So yes, it gives the it is also submitted. Now we will look at the edge cases. Edge cases in this case will be like array length is greater than equal to 1. Let's take an array length which is greater than equal to 1. Let's take an array length, and let's take k is equal to 1. This will gives us the answer number 2, because after 1 our first missing number will be 2. If k is 2, our second missing number will be the first number missing number is 2, second number missing number is 3. So this is the edge case. It will give the yes right answer 2 2. Now let's take 2. It will give the right answer, which is 3. ES3. Now let's take a look at time complexity in this case. The time complexity in this case is basically uh, big O of n. Why? These statements will run constant times, constant for constant. Then these sorting basically in Python there's a built-in function called sort, which has a time complexity of n log n. And and by using these statements, I have the time complexity of my program will be O of n, big O of n. So that's why I haven't used the sort function. I've used these five statements. So it gives a time complexity of O of n, and then these will also give the time complexity of O of n. So one of the rule in time complexity is we have to discard the constants and take the dominant term. So sorry, this will be n. Let's redo this. Okay, c plus n plus n. So we will discard the constants and take only the non-dominant term. In this case, it's 2n plus n, 2n. There's also constant 2. So our time complexity will be big O of n is equal to n. So yes, now let's go to the next question. So yes, let's continue question number 2. So question number 2 is insert interval. So basically you are given an array of non-overlapping intervals where intervals I is equal to start and represent the start and end of the interval. An interval is sorted in ascending order by start. You are also given an interval, new interval, which have start and end that represents the start and end of the interval. So insert the new interval into intervals such that intervals is still sorted in ascending order by start, and intervals will still does not have any overlapping internals. Merge overlapping intervals if necessary. Return the intervals after insertion. So basically we have been given an interval. So for example, in this example number 1, interval 1 is given and new interval is given. First we have to insert this new interval into intervals, and then we have to return the non-overlapping intervals. So basically we have to merge the uh, intervals which are overlapping and then return the non-overlapping intervals. So in this case 1 and 3, 2 and 5 are overlapping, so we return 1 and 3, 2 and 5, 1 and 5, and 6 and 9. Likewise in example 2, new interval is 4, 8. 4, 8 is overlapping in these two intervals, in these three intervals. Like so our so this will merge and will give us 3, 10, and the remaining will come as it was. So the output will be this. So let's go to the constraints. So interval length should be greater than equal to 0, less than equal to 10 to the power 4. The interval the intervals the list within the interval should be equal to 2. For example, this is case is 2. Okay, the start and end pointer, start is should be greater than equal to 0 and end should be less than equal to 10 to the power 5. Intervals is sorted. Okay, so basically intervals which are given to us is already sorted. So and start in ascending order. New internals intelligence should be equal to 2. The intervals which is given with the given intervals, that is new interval, should be equal to 2, and start and end of that in new interval should be greater than equal to 0 and less than equal to 10 to the power 5. So let's jump to the algorithm. So uh, basically what I implemented is merge interval pattern. So let's take this example. So basically what I did is uh, I insert that interval into this interval. So what I get 1 3 2 and 5 and 6 and 9. After that I uh, I check in condition for the merging intervals. Like in this case, I what will I check it? I check that if 3 is less than equal to 2, if 3 is less than equal to 2, that means that it is not merging. If 3 is greater than equal to 2, then yes, it's an overlapping interval. So then I do is I check 3 with 5, that which is maximum. So in this case 5 is maximum, so I change 1 to 3 to 1 to 5, and then I check for the next interval that if uh, 5 is greater than 6, no, 5 is not greater than 6, so it means that it is not overlapping. So uh, I will append that next interval into my uh, newly created interval, which I take in this algorithm is merge. So firstly I append first list, then I check it for the second list. If it merges, I take the maximum. Then I check for the third list. If it merges, no, it not merges, so it will come as it was before, 6 and 9. So this will be my output. So now let's go to the algorithm. So yes, as you can see, intervals append. So basically I append a given interval, which was given new interval, into the previous intervals, like in this case is 1 3 and 6 9. After that I sort it according to the first zero index. It means that first index, first number, like 1 6 2. So when I insert it, 2 and 5 will be at last. After I sort it, 2 and 5 will come between these two intervals. So after that, I took a merge uh, empty list. After that, I trade for loop in which I check that if interval is, if there's no not merge, if merge is empty, so append it. So in first case 1 and 5 will come. After that, if merge is less than minus 1 1 less than interval 0, it means that 3 is less than 2. If 3 is less than 2, so it means that uh, if 3 is less than 2, so if 3 is less than 2, it means that it does not overlap. If 3 is greater than 2, then this will not this statement will be incorrect, and this statement will execute. So in this statement I am checking that if 3 is greater or 5 is greater, take the max out of 3 and 5. So 5 will be taken, then 5 will be in the our merge list. Then we will check again for the next list. So it will check that if 5 is, if not merge, this condition is already wrong. And then for we will check that merge minus 1 less than equal to interval 0. Interval 0 in this case will be 6 6. So 5 less than 6, no, 5 5 is less than 6. Yes, it's less than 6, so it's not overlapping. So we'll append the interval and we'll give the output in the end. So let me run it. Yes, it is correct and I submitted. Yes, it's also correct. So as the edge cases would be, edge cases in this this problem be like length of 2. Okay, for example, if there's only if there's no list, it will return the it will return 2 and 5. 2 and 5, it return 2 and 5. This is an edge case. For example, if there are no intervals in the list, uh, let's take 1 and 1. So it returned the only two intervals, 1 and 1, 2 and 5. So this was the edge case. So now let's check the time complexity. Time complexity in this case will be um, n log n, because of the fact that I'm using this sort function. So there's also for loop. So these statement will run um, n times, but this due to this sort function, my time complexity of overall program is n log n, and n log n has greater impact than linear. So my time complexity would be uh, uh, O of n is equal to my time complexity would be n log n, because of using this building function. So yes, this was my uh, algorithm. So yes, let's jump to question number third. So so the question is rotate list. Given the head of a linked list, rotate the list to the right by k places. So basically, we have been given a linked list, like in this case, 1, 2, 3, 4, 5, and we have to move to the right by k places. So in this case 2. So it means that we have to move two times to the right. So which will be, first rotation will be 5. 5 will come here, so it will become 5, 1, 2, 3, 4, and then 4 will come right before 5. So for the output will be 4, 5, 1, 2, 3. In this case, the head is 0, 1, 2, and we have to move to the right by 4 places. So 0, 1, 2, then 2 will come here, 2, 0, 1, then 1 will come here, 1, 2, 0, then 0 will come here, 0, 1, 2, and then 1 will come here, 2, 0, 1. Also, one thing, that if we have, for example, 5 nodes and we have to move 5 places, so it means that the output will be in that case would be same, which was which is the input. So basically 5 nodes and we have to move 5 places, so output will be same. Okay, the algorithm which I implemented is in universal in place reversal linked list. So basically what I did is, if in this case 2, so we have it means that we have to swap we have to reverse the last two nodes. We have to reverse the last nodes. So what I did is, i I cancel this connection between 3 and 4, and then what I did is um I give the uh, what I did is I give that uh, 5 5 next to 1, so it will be reverse in that case. So basically, first I have to do is I have to take the length of the linked list length, which in this case will be 5, and then what I did is I calculated the k. So firstly, I have to take the length of the linked list, then I have to go to the this node till this node. So going to this node, the formula will be length minus k minus 1 would give up the location to this. So after we go to the third node, what we do is we uh, give the next three next to null and cancel the connection between 3 and 4. After that, I simply give the connection of 5 to 1. So it basically will give the same answer as it is. So now let's come jump to the, also we have to discuss constraints. So constraints in this is that the range of nodes could be 0 to 500, and node value within the nodes are can be minus greater than equal to minus 100 and less than equal to 100. And k, which is uh, how many position we have to move to the right. So it will be 0 to greater than is equal to 0 and less than equal to 2 to power 10. So now let's jump to the code. So basically what I did is I firstly checked that if there's no head, if there's no head, there's no linked list, so return the empty linked list. After that I take length as one, because if we knew that there can be at least one linked list, so we take the length one. Tail is equal to head, while tail next, while tail dot next means that it have to iterate to all the linked lists. And what we did is we calculated the length is first, so one in this case, so we will increment length and check that how many nodes are there in linked list. After that, the condition what the condition that I told earlier, that if for example there are 5 nodes and we have to and we have to check that if k is also 5, length is also 5 and k is also 5, so it means that the answer will be the same as it is the input. So what I did is I k is equal to k mod length. This means that if k becomes 0, it means that it is the k is the multiple of itself. So it will be, for example, if k is 5, 10, 15, 20, and length is already 5, so it will return always 0. So I will return the same head as it was before. Now what I did is I also take a new variable current is equal to head, then I iterate to it till to third node. My current will be at third node. Then what I did is I take another variable and assign that node to that variable. After that, I what I did is I broke the connection between 3 and 4. I take the 3 next to none, and the last node uh, which our tail was, this tail was at 5. So I basically what I did is I take that 5 and give it next to 3, first node, sorry, which is in this case is, so our output will return the correct answer. So let's check it. Yes, it gives the right answer. Okay, it gives the right answer. So the edge cases in this algorithm will be, like I said, that if it is 5, k is equal to 5, it means that it will return the same head. Yes, it will return the same head as well. So let's take another edge case. For example, if like in this constraint, number of nodes is equal to 0. Let's take if we have 0 nodes, so what will it will give? Let's take a look. It will return the 0 because this condition will become true. So that was my algorithm. Now see the time complexity. Time complexity in this case will be linear, because this will run constant time. This will run linear time. This will run constant time. This will run linear time. Then for loops comes, which means that linear time. It will this statement will run linear time. Then this statement will run constant time. So basically, uh, our time complexity will look like constant. First constant comes here, then constant, then n plus n, constant plus n here, and then constant also, then n, then constant comes, then what comes also, two constants comes, then n comes. So likewise we have n, then three constants also in the end. So what we'll do is the number, one of the rules of time complexity is we have to remove the constants and take the dominant term. So in this case, uh, we have to remove the constants, sorry, it is n, and take the dominant term. So after the addition of 3n, after addition of n plus n, this comes, and there's all another constant 3. So our lead time complexity and the end will be O of n is equal to n. Okay, the space complexity would be we, as we are using no extra space, and also we are using um, as also we are using no extra space, and also we are using the pattern, pattern name is in place reversal linked list. So space complexity will be O of n. So yes, this was my algorithm. Thank you for watching. Allah Hafiz.